Anyway, so here's the idea though. If you flip 10 coins and you got 7 heads, 3 tails, 70-30, that would not be very unusual. That may happen, I don't know what the odds are. I could calculate it, but I don't feel like it right now. That would be pretty common to see a result like that, 7-3. However, if you flipped 1,000,000 coins, would you ever see 700,000 heads, 300,000 tails? No, you wouldn't, because over a large sample, a regularity sets in. Even though there's randomness to a problem, each flip of the coin is a random event. Because the probabilities are 50-50, you expect that over a large number of coin tosses that you're going to be very close to 50% heads, 50% tails. And so if you flipped 1,000,000 coins, you would probably see somewhere on the order of 501,000 tails and 490,000 heads. 499,000 heads might be 50.1% versus 49.9% over a very large sample like that. In other words, the regularity sets in over a very large sample. All right, so I hope that makes sense. The real drawback to the videos is that you can't ask me questions, so I have to try to anticipate some questions that you have based upon past experiences in teaching this course live. And anyway, that's an idea there that I hope makes sense. Now, sometimes statistics is I've heard it called common sense verified by calculation. So not everything we do in statistics is going to appear to be common sense. Some of it's going to be maybe a little baffling when you first see it, but a lot of it I think you will find to be fairly common sense stuff. And but we can verify it through calculations. So that's one such thing. We can verify that through calculations, that if you were to flip a very large number of coins, that you would tend to be close to 50% heads, 50% tails, very close. Much closer than if you flipped only a handful of coins a few times. So, anyway. By the way, I love I don't know where to put this quote, but I love this quote. It's a very famous quote about statistics. And it's attributed to Benjamin Disraeli, who was a British Prime Minister around 1871, somewhere in that era. And Disraeli one day said, there are 3 kinds of lies. Lies, damned lies, and statistics. And so you may have heard the saying that people lie with statistics. But we'll talk about that as we move along here, to how statistics can be misleading. And as you saw in the Harry Truman example, it was not intentional. The media did not intentionally try to mislead people. That Dewey won because they had egg on their face when Truman won. But it is possible to intentionally attempt to mislead through statistics, and we'll see some examples of that, I think possibly in chapter 3. All right, well, you're going to find a lot of what I do, particularly early on, is kind of foreshadow the terminology, the ideas, the concepts that we cover in this course. And I may sometimes get a little bit ahead of myself in describing things. But that my purpose is to get statistical thinking into your head. And statistics is really a subject about a couple of difficult but large concepts. And so that's the way I see it at any rate. So there are several, or a handful, we'll say, of very important large concepts we have to wrap our head around. One of the big ones is, what does it mean to be significant? That's a big concept that we grapple with throughout the whole course. And anyway, but there's also a lot of terminology, and so we have to build up a lot of terminology in this course. And it seems to start around page 13, where the author says what a probability is. A probability, we're looking on the, again, I tend to, when I quote pages, I'm normally quoting these little pink sections in the book. There we go. They appear on those pages. It says a probability is a number between 0 and 1 that tells us how often a particular event will occur. Okay, so we use probability, as I mentioned, probability is the basis of this course. And probabilities cannot be negatives. It would make absolutely no sense to say there's a minus 50% probability of something happening. This makes no sense. And a probability cannot be more than 1 or more than 100%. So you can't say there's a 110% probability of something happening. That makes no sense. So probability is a number. It's between 0 and 1. Or you could say it's between 0% and 100%, depending on how you want to look at that. And it tells us how often a particular event will occur. All right, so there are actually 3 kinds of probabilities. And now I wish I had my board behind me to write this on. But I'll describe them verbally. 3 kinds of probabilities out there. One is a theoretical probability. A theoretical probability is one that is sort of predetermined by the physics or some other aspect of the situation. For example, flipping the coin. 50% chance of getting heads when you flip a coin. If you roll a die is singular for dice, has numbers 1 through 6 on the little cube. When you roll the die, you have a 1 out of 6 or 1/6 probability, or about 17% probability of rolling a 2 or of rolling a 5. And those are theoretical probabilities. When we know theoretical probabilities, then statistics can be somewhat more easily determined. We can calculate statistics involved with that. Most of the time, however, we don't deal with theoretical probabilities. We deal with experimental, what's it called here? I'm drawing a blank and I don't want to stop the tape.